Welcome to another episode of the Concrete Logic Podcast. And today I have Leo Zhang with the Conco Companies. He is a virtual construction manager in San Francisco, and he is a ACI committee. He's on the ACI committee 131, which is Building Information Modeling of Concrete Structures. And he's also he is the chair of ACI 117, subcommittee 117L, which is laser scanning. And he just got back from the ACI convention, so we hit him up on a good time. So he's all excited to talk to me about laser scanning. But before we get started, I'm just going to remind you, everyone that listens to the podcast, this is a value for value podcast, meaning I do my best to provide you a value each episode. So if you learn something from Leo today, you can support the podcast in 3 different ways. And the first way is pretty easy, is if you like what you hear from Leo and want to share it with a colleague or a coworker, that's easy value you can provide back for the podcast. So share the podcast. The second thing you can do is you go to concretelogicpodcast.com and you can contact me a couple ways. There's a contact button on there, and there's also a little microphone in the bottom right-hand side. So if you hit the contact button, it shoots me an email. If you hit the little microphone, it actually records a voicemail. And then what I'm looking for from you is a topic or a guest suggestion. And just like Leo today was a suggestion from a listener, so I reached out to Leo to bring him on because he's an expert on laser scanning. So that's easy too. That's the second way. And the third way is you can donate to the show. And you're like, why would I want to donate to the show? You want to donate to the show because you want to support the podcast so we can pay for the things that we use to make the podcast. Podcast isn't free. We use software, hardware, all kinds of stuff, and then editing and all that good stuff. So the donations go towards that. And the reason why we ask for donations versus getting sponsors, because me personally, I do not like listening to podcasts and hearing advertisements, nor do I want someone that advertises on our show and gets upset because I talk to Leo. Maybe Leo did something to somebody and they don't like Leo and they say, hey, why'd you have Leo on the show? So this way we don't deal with it. It's a listener supported podcast, so we can talk to and whoever we want and talk about whatever we want on the podcast. So that's the reason why we do that model. Okay. With that, Leo, thank you for coming on the show. Like I shared with you guys, Leo, he's the virtual construction manager for the Conco Companies. And today I wanted to bring him on because he's an expert on BIM and laser scanning. Leo, to start us off, could you just give us an overview on what BIM is and what laser scanning is?
Good morning, Seth. Thanks for having me. So, in general, what BIM means is building information modeling. So, it's use a 3D model, but it doesn't stop with the geometry of the model. It has information in the model, including, material types and construction information, sequencing, all those information within the life cycle of the model for the construction. So it's another term of talking about the BIM. People talk about virtual design construction, which is VDC. Some people call it digital twin, virtual construction. There's a lot of buzzword, but they all come handy with you have a model, you have information in the model, and you use that for construction management and digital layout and all that for construction projects. So that's easy my interpretation of what BIM means for construction. And laser scanning is some of the organizations. Laser scanning is part of the VDC operation. What laser scanning is, you capture with the optical instrument to collect all the dimensional information, and some of them be part of the VDC operation is because is like a model. And the other side is a survey tool as well. But we're going to talk about more details about laser scanning. But for now, we talk about BIM. That's what I feel like it is.
Okay. Like I was sharing with Leo, I'd be hard pressed to run across a project these days that doesn't require some kind of BIM requirement. It seems to be in every contract or specification for a job that we run across. So essentially, it when I got started in construction, there was nothing like BIM. There was no modeling or laser scanning. Everything it was on drawings. Everybody used hard drawings. I don't even think we used PDFs back then. But
Blueprint.
when the BIM for me and the laser scanning, it just makes it so much easier to see what you're dealing with. Versus when you looked at drawing or a plan, you got to, for guys that have been around the business for a long time, you can vision the building in a 3 dimensions. But
Yeah.
the modeling now, man, it's amazing what you see now, and you can really see things, and it just makes it so much easier. But did you want to add to that?
When we talk about BIM, I basically, from a contractor's perspective, we talk about how to use that. It all starts from the design phase. The architect, the engineers, they design, and now they use more and more 3D, like Revit, Tekla, and all that. So they design in that platform, and then because ACA 131 BIM committee, we're developing some document. It's not published yet, but it's IFC exchange. So that's a industry standard format to exchange the information through different platform. So it's got an EM15, EM6, which is focused on the rebar, and EM20 is for construction sequencing. So that there's basically you transferring the information, not only the geometry of a cool model in 3D, and also there's information in it like rebar coverage, rebar size, the steel type in the model itself. Ideally, if we have a fully divided BIM process.
Are you finding that you're a concrete contractor too? Are you finding like all the vendors and the subtrades that you work with, are they on board with detailing models down to that point, like the rebar and post tensioning?
There's a good, I think a lot of those also comes with cost effective. And that's when it decide if there's a need for a fancy 3D, especially rebar or PD cable model, that's the big factor gonna kick in. But it's just maybe a dream if from the designer side, they design all those information in that platform with all the information embedded and then pass to a subtrade like us. If we are a detailer, just gonna grab that information right away and then we set for fabrication it's a dream hopefully gonna come true.
I guess the question that comes to my head is, are we going to build off of that? Meaning, I understand like clash detection, where you're trying to find where things are hitting each other before you get out in the field and you actually install them. But do you see a point where we're actually bringing the model out to the field to, say, install rebar or install post tensioning? Do you see that?
Definitely. It's pretty good visualization tool to be proactive and see that clash ahead. We have a project recently. There's a couple of lift core wall after the concrete slab cuts in place, and another 5 lift on top. And those core wall has the 600-pound embed on the boundaries, and those big with the big stud, and pretty congested rebar on the boundary. So I think we had not a full model, but just focus on one area and show that potential clashes between the embed and bar. That helps.
Yeah, no, I definitely see that. We use it that way as well, as the embeds are a big part of that. But as far as right now, the rebar installer, he has a shop drawing that he goes out and looks at it, and then he installs rebar per that shop drawing. I guess my question is, do you ever see a rebar installer actually taking like the model and using it out in the field? That's the part that I have a hard time imagining.
For me personally, I haven't. I had some startup company that came to show us some cool VR goggle. We can project the 3D bars location-wise on the field, so the rebar foreman, they can see the part in the space and to lay it out. But it's just a prototype. But I heard there's some projects. There's a aquarium job in Seattle, and they curve the shape and all those bars. They have a pretty good developed BIM model for that job. But in terms of the field to use it directly, I haven't, at least my personal experience, I haven't seen.
Yeah. So that's more like augmented reality, right? What you're talking about, where
Oh yeah,
you're augmenting what's out in the field using those goggles. I know what you're talking about. I've put them on too.
It looks pretty cool, and it worked, but until the technology is stable enough, so they don't have to deal with the hassle of repositioning and now deal with that IT stuff.
I get a guy. I met somebody at a conference. They did augmented reality. They're a company that just does that, and I see potential in that. Maybe not necessarily. Maybe down the road, rebar, but I really see it using it as for form work, so you can see where the form work should go. I think that has real potential. But since you're on the subcommittee for laser scanning, I know you're passionate about laser scanning. So let's talk a little bit more about laser scanning and how it's being used. I guess we could talk a little bit how it interfaces with BIM. But can you talk a little bit more about laser scanning, about what you're using it for?
Laser scanning's been around a few decades, and recently with more hardware, software developed more and get lighter, cheaper, and easier to use, I think a lot of business start looking into this solution. And it covers not only the construction, is some people call it reality capture, is part of the reality capture, and it can be used on multiple different industries. But we talk about construction, especially concrete construction. It can be used first. If people don't know what laser scanning is, it's gonna be a long. I keep it short. It's an instrument, it's a survey instrument set up on a tripod or a different type, but it's emitting the lasers and collecting the distance information to the scanner position, and basically collect the 3D information and generate a result. It's called a point cloud. So that point cloud is basically some manufacturer can measure millions of points per second. So it's basically mapping the whole real world. That's why it's called reality capture. Some people call it that way. So with that being said, during the pre-construction phase, people can just scan the whole site, and you can see all the fencing, the power line. If there's a concern on the power line too close to the concrete slab edge, so you tie that whole scan to a survey control, it's drill reference. So you can see some problem ahead. For example, we scan leggings, and there were some jobs we found part of the leggings is intruding out of the property line. So there's a problem. And so another use of that for pre-construction, you can use for planning the truck route, your site logistics, because you can have basically a real world one-to-one 3D model to take any measurement that you want to check, instead of have your safety guy go to the field and measure, and they can't measure to the power line distance. Just have to eyeball it or reference somehow. So that's a pretty good use for pre-con.
Are you using drones for the site example that you gave? Are you using a drone for
that's
flies over the top, or are you setting up a tripod? How are you doing that capture?
It can be done either way. It depends on how accurate you want to measure, right? Because there's a lot of talking about, if we only talk about laser scan, is about the LiDAR, but there's other solution like photogrammetry. Like if you use drone, one, you can use the camera on the drone for photogrammetry if your tolerance is not that tight, or there's drones with LiDAR sensor. You can basically, it's the same sensor is shooting the lasers and do the measurement. And there's mobile scanner that you can, is handheld, you just walk around with it, or just put on a backpack. I'm sure you've seen those people just walking around with monitoring. and tripod based. That's the one me personally use most of the time because I feel like the terrestrial scanner, stationary and tied to the controller, is pretty accurate that way. But technology is evolving. You never know, drone lidar or mobile scanning, how accurate you can get. It probably surprised sometimes is as close as the terrestrial scanning.
Is the how fast is this information that you're scanning? How fast can you see it? Is it instantaneous out in the field, or do you have to gather the information, take it back with you, and then put it in a model, or what's that process look like?
That's a great question. And again, it depends on what hardware used. So if a lot of a drone, after you fly with a camera sensor, those pictures, photos can be uploaded to the cloud, even just right away or through the phone with the Wi-Fi connection. In those cases, in other mobile scanning solution, you can basically do it live and upload to the cloud and cloud processing, then give you the result. Some of them in a few hours, maybe some in a few days. The other workflow that we divide up is using the terrestrial scanner. You have to set up and then do this called a registration to stitch all the setups together and tie to the survey control points. So there's a procedure. If you also depends on how accurate you want to achieve. So the more time gonna take, if you need a more accuracy, I would say, and you need to tie to the survey controls. But in general, from anywhere a couple of hours to a day to some solution gonna take maybe 2-3 days to give you the data back.
Yeah. So you go out there, you scan it, and then depending on how accurate you need it, it'll take a couple hours. Are you using it? Are you using your laser scanning for when you're actually pouring concrete yet? Like when it's still wet? Are you using it for that?
Before that is also another good tool for quality assurance. Like for example, a couple days before we pour the slab, all the formwork's in, all the embeds installed, and because the nature of laser scanning is you can visualize anything you can see in the scan, right? So people do a scan on the deck, just 20, 30 setups or even more, depends on how much details you want to capture. You can see those edge forms, any formwork, house, embed. So depends on line of sight. As long as you can see them clearly in the scan and they geo-reference to the grid line and benchmark, you can overlay to that's the combination between BIM. You can throw the BIM model into that same scan, and anything that's deviated, you can basically do the quality assurance check before the port and fix it before it happens. So that's a pretty good tool to avoid any rework or repair. And then like when you ask about the live pour, I think you talk about the scan on the pour day with the finishers to give them the feedback of high low spot before dry. That's something it can be done with the scanner. I know a lot of contractors doing it. And as long as there's a resource, you have the crew that is capable of doing that. And I'm sure, and we just did a test a couple of weeks ago on our job. It's in Berkeley, it's elevated slab. It's pretty small, 5,000 square feet. So we scan around 10 o'clock, 2-3 hours after the pour starts, and found some hump, like 5/8, half-inch high. And we tell the finisher just go back and re-strike it, and then we recheck it. It works. So eventually, that's a pretty good floor that we turn over. It is time consuming. It's just gonna be the resource, your operator, the scanner gonna be on that site for the whole day. But
like you mentioned earlier, you got to find a balance on the cost and is it worth the cost having that done?
Think about how much gonna grind or deal with the client on the floor being not flat compared to you spend 8-10 hours on a poor day. I think it worth it.
Yeah. So what's your favorite use of laser scanning on a job?
My favorite thing is the pre-pour. We call it pre-pour as built or pre-pour quality assurance. So basically, you being proactive and avoid any mistake. And every time, there's nothing perfect. Even you have a street slab edge, and your field crew snap the line from one end to the other, and maybe one point in the middle, and the line not tension, and then your form is just bowed. Or even the airplane is not plumbed, and you can easily see your form is out of half inch or 3/4 sometimes. So those information, as long as it's done in time, is very valuable to as a concrete contractor or contractor that does cell performance. It helps to avoid any mistake. And we've been caught a lot of opening size that change from drawing because you use the drawing from the designer and then see this different. And then you call your foreman there and they said, oh, the MEP gave us a new drawing the day before the pour and we just changed the size. Now that's in reality captured. And at least there's information missing in between, or there's whatever kind of conversation needs to be. We know how it looks. If you don't have a visualization tool, then how are you count down the commenters, just check around and hopefully they can cover all the stuff. There's not as easy as you just do a whole scan and can see everything.
Do you find that the laser scanning can be overwhelming as far as the amount of information that you gather from it? How do you balance that?
I think to that point, in terms of overwhelming, if some company just got the sales page and there's a pretty good scanner, fast, and just buy the machine and didn't have a right crew to be trained or excel on using that, those organizations may be overwhelmed and see struggling with it. But I would say if you have a champion with your own company that loves it and get trained for it, the information is not really that overwhelmed.
Are there any limitations that you run across so that you hope that laser scanning will accomplish it at some point?
I've been testing different solutions. Talk about a mobile scanning. You can just handheld and walk and do the fast, or like you mentioned, use drone to scan it. Hopefully, they can be in the range of accuracy as when we talk about the concrete tolerance. The measurement needs to be no more than a third of the concrete tolerance. So let's say if we measure the slab edge, which is plus and minus 1 inch tolerance per the ACI 117, our measurement accuracy needs to be less than a third of an inch, give and take about a quarter inch. And so that's why there's no study showing, even though the sales page, they say, oh, my mobile scanner or the drone can achieve that, it's still not proven that it can be that accurate. But the limitation was the faster you can collect the data and do the analysis faster, the field can have more time to take action to, if they need to move anything, they can't wait until the poor day to do it. So I would say the speed is, in terms of using for pre-pour as field, that's a big factor.
Is that the purpose of the ACI 117L subcommittee? Is you're setting the standards for that, or what are you all tackling in that committee?
So currently, we developing a tech note is just give a basic information about laser scanning for the concrete industry, because there's not much. Scanning's been everywhere, but for the concrete industry is still relatively little bit behind. So we want to give the basic information to the readers, including owners, the GC, the concrete contractors, the inspectors, surveyors, just some fundamental knowledge about what scanning is, what you need to be aware of in terms, like you mentioned, limitation. There's some applications from scan is just not good for certain application when we talk about checking the tolerance. And some information about deliverable work. So people have been seeing different types of heat maps, right? To show I'm sure you talk about it, the Amazon job is like the flat, the floor contour, the vertical plumpness, and people is sometimes you see a heat map with no legend and just some colorful, beautiful pictures. And I assume green is good, but people maybe think blue is good. So there's just not standardized. We not try to standardize for this time, but just give the information to the public so people know there's something you need to be careful and there's some limitation of a certain application there.
Okay. So is there going to be some kind of certification at some point, you think?
We haven't. We have a section talk about a qualification of operators, but in terms of certification, I don't think there's available yet. But a lot of our organizations trying to develop some sort of certificate for the scanning. But I think for now, there's really not much. There's what and people just buy the machine and do it, and they all say, "Oh, my scan is the best." Or the manufacturers, they say their solution is always fast and best accuracy.
Is it fair to say that laser scanning's taken over for all as-builts now?
Still, we talk about it as build a critical thing, anchor bolts in the foundation. We talk about a 2.5-inch bolts. It's still people still hire the surveyors to do that, right? There's licensed surveyor going to certify and check those bolts. The critical, very critical. You talk about an 1/8 inch or less, XYZ. Still, totalization is the way, but scanning can collect much more information from one shot. So there's give and take. You can collect much more information and see a big picture if there's any potential issue compared to you have very precise shot, but you can only shoot a few certain things. It's not replacing anything. It's just another tool in your box. Just like a sauce, you have different kind of type of sauce for different work.
So you're saying don't throw away your total station yet? Is what you're saying?
For sure. and we need a scanner. You need, and in our work for concrete, you always need a tie to the survey controls, which is sometimes you need a totalization to transfer some controls, or if you don't grab the control directly from the surveyor. So the totalization is still fundamental, and I think for sure it's not replacing that at all.
Not yet. But
Not yet, and also it's different use because scanner is only collecting the data. You're not staking anything.
All right. I think this is a good spot to pause today, Leo. Unless you is there something that we didn't cover that you wanted to cover?
No, I think because of time, I can run this all day long. But I think we covered some topic about scanning and start with the.
Yeah, if there's something that you want to come back and talk about specifically with the laser scanning as the technology improves, definitely have you come back on. Leo, what's the best way for folks to reach out to you to learn more about what you do?
People can reach me through my email. It's lzhang@conconow.com, CONOW. But we can put the link on the channel or somewhere.
We'll put it on the show notes as we always do. Leo, thank you for coming on the show. I appreciate it. And folks, until next time, let's keep it concrete.